Hello everyone, I'm Murali Sridharan, pursuing my second year doctoral research studies at M3S Research Unit, University of Oulu, Finland. I'm about to present our research paper titled Data Balancing Improves Self-Admitted Technical Debt Detection. The problem in focus is that there's a huge class imbalance between SATD and non-SATD comments that impacts SATD detection with AI techniques. Generally, AI techniques expect the underlying distribution of the data used for training to be normal, that is, balanced data split among the categories. However, the real-world data is often skewed. Further, the existing literature lacks evidence on the choice of the balancing techniques for SATD detection. To this effect, we conduct an experiment and evaluate multiple balancing techniques for SATD detection in within and cross project setup. In within project setup, the source code comments from the same project are used for training the machine learning model, whereas in cross project setup, the source code comments from multiple projects are combined together for training the machine learning model. The overview of our experiment is that we first process the source code comments and then train the machine learning classifiers logistic regression, random forest, and XGBoost with and without balancing techniques for SATD classification. The baseline classifier performs the SATD classification without any explicit balancing technique. The data sampling technique SMOTE randomly synthesizes data samples of the minority class. In addition, synthetic data samples are created in sparse regions. Another data sampling technique, borderline SMOTE, randomly synthesizes data samples along the decision boundary between SATD and non-SATD classes. SVM SMOTE is a variant of the borderline SMOTE that employs SVM algorithm for synthesizing data samples. In the classifier level balancing technique, COST, higher weights are assigned to the minority class such that each misclassification of the minority class would penalize the machine learning model during training, with the aim to learn the features of the minority class better. A quick walkthrough of the results of our experiment. For precise detection of SATD comments, the balancing techniques borderline SMOTE and SVM SMOTE consistently contribute to higher precision in within project setup. For cross project setup, the baseline classifiers contribute to high precision. In particular, the Ensemble classifier random forest without any explicit balancing technique contribute to higher precision in detecting SATD comments. For extensive detection of SATD comments, the balancing techniques SMOTE and ADASIN consistently improve the recall scores for all the classifiers in both within and cross project setup. For improving the classifier's distinction capability of the SATD comments, the balancing technique SMOTE consistently improved the ROC-AUC scores for all the classifiers in within and cross project setup. For balancing both precise and extensive detection of SATD comments, the data balancing technique SMOTE consistently improved the F1 score for all the classifiers in within project setup, while in cross project setup, the data sampling techniques SMOTE and borderline SMOTE consistently improve the F1 scores for all the classifiers. We compared our consistent top-performing model XGBoost with SMOTE and borderline SMOTE balancing technique with previous works. First, we compared with Huang et al.'s approach where they employed an ensemble of naive-based multinomial classifiers with feature selection as the balancing technique. Our model outperformed the naive-based multinomial ensemble by 14.57% and 5.45% in within and cross-project setup respectively. We then compared with another previous work by Ren et al. In which they employ the state-of-the-art deep learning classifier Convolution Neural Network with COST as the balancing technique. Our model outperformed CNN by 10% in within project but fell short in the cross project by 9%. One of the key takeaways of our work is that the results of our experiment serves as a baseline for practitioners and researchers to choose metric-specific balancing technique for SATD detection. Another key takeaway is that the classical machine learning algorithm outperforms deep learning classifier for SATD detection in within project setup, although it does not scale well in cross project setup. Thank you for your attention. Open to questions now.